Hey everybody, this is Caitlin Miller, your teen librarian from Hewitt Public Library, and this is Tracy.
Hi guys.
Programming planner. We are very excited to announce this week's guest. This is our last performance for the summer. It has come to an end, but we're going to end it with a bang, right? All right, so we're happy to announce Mad Science.
Yay. All right, does that mean I have to go ahead to start?
You are good to go, Adrienne.
Oh yeah, I'm good to go. Just making sure. Okay, I was like, that's official. All right, welcome everyone to the Mad Science Laboratory. My name is Mad Andrea. I'm very excited to have you here. Now, one of the things that I love being a mad scientist is I get to meet people all over Central Texas. And I know we're not meeting in person, but I still love the virtual science. So the things I'm doing today, if you're excited about them, maybe you could try them at home or get a book at the library and learn a little bit more about some science that you can do at home with a grown-up, of course. I don't have a grown-up with me, but as you observed, I'm super old, so I think I'm okay to do these by myself, right? So we're going to be dabbling in all different areas of science. Well, lots of them. We are going to start off talking about forces and the laws of motion. There are laws to motion, any kind of movement, right? Dancing or even just the lack of motion, sitting still. Sir Isaac Newton, a famous scientist from a long time ago, noticed that there were different things that always happened. And we're going to talk about the first law of motion, and it's my favorite. It's called the law of inertia. Now, all objects have inertia. What does that mean? That means if an object is at rest, it will stay at rest unless acted upon by an outside unbalanced force. Do I mean like sleeping rest? No, I don't. I mean still, okay? So an object at rest is going to stay at rest unless something makes it move. And an object in motion is going to keep going in motion unless something makes it stop. Now, sometimes that something could be you, could be grandma, or it could just be maybe friction of rubbing up against something. So right now, I'm going to do a little inertia activity for you. I have on this tray cups. Boop. And the cups have inertia. They are at rest. On top of each cup, I put an index card. You may have observed with your scientist eyeballs, the index cards are also at rest. Of course they are. Now I'm going to put a third object in here. I'm going to put a penny on top of each card, kind of in the middle. All right, at rest, at rest, at rest, at rest. I want to put something in motion. I do. I'm going to be the outside force. Now, I love science and I love Star Wars. But when I say force, I don't mean like, I mean you know what I'm saying? Like that's right. A push or a pull. That is what a force is. Easy definition. So I'm going to be the outside force. And I'm going to take my thumb and my finger and I'm going to try to flick and move the card out from under the penny. That sounds easy. But remember, they all have inertia. So what I want to do is use that to my advantage and move the card out where the penny falls into the cup. Now, seems crazy. There is a force that will pull the penny down. Okay, I'm not going to say it yet. If you know it and you want to show that you know it, share your knowledge, you could type it in chat and I will announce the force after I finish, okay? I'm sure you know the force, right? Pull things down, you jump up, you have to come back down, right? Okay. So, I like to hold the cup still with one hand. Just kind of give me a little advantage for my rest. Oh, people are answering it. Okay, sorry. I can't read and do science, apparently. So, here we go. Oh, I missed. Thank you. It's hard for me. I think I got to move these cups off. I tried to make it easy for my setup, and it's not working so well for me. No. Okay, so I missed you. Thank you. Got 3 out of 5. I will take it. Normally I do 5 out of 5. Don't be sad. Okay, it's okay. If they're too close together, we've got that extra force, and there's action-reaction. That is another law of motion, right? Meaning, if you do something, something's going to happen. You push the door's going to move, right? I flicked the card, and it moved out of the way. And then gravity, as our friends have said in the chat, pulled the penny down. Now, if it goes in the cup, it kind of depends on a couple of factors. One, the bumping motion, but also if I have the penny centered, and sometimes I don't pay attention. Okay, had to do it again for my mental well-being. All right, so gravity. Gravity's kind of a bummer sometimes. Keeps us down. Like I said, if I jump up, I can't stay up. But I do like gravity for a super important reason. Gravity brings our atmosphere down to us. Atmosphere is like, think of like a little envelope of gases. And I like to breathe. I'm sure you do as well. So gravity brings our atmosphere down so I can get my oxygen. Oh, you too. You can get your oxygen. All right, so that way we can breathe and be happy and healthy. But something that is interesting about gravity. It's really important when you're trying to find where an object can balance, all right? It's called center of gravity. Some scientists call it center of mass. All objects, all matter has mass, right? Think about how much of something fits in. And a lot of people compare it to weight. So let's do this. I have 2 objects. One I use to measure and one I use to eat. I'll let you decide which is which. I hope you know. I've never eaten with a ruler. I guess it could be done, but I've never done it. Okay, so ta-da! What am I going to do? I'm going to find the center of gravity for each object. This is something you could do at home. You don't want to do it with like your baby brother, baby sister, or your pet. That would not be good. But something like this is pretty easy. A pencil too. I'm going to try 2 fingers. And what I want to do is find out where the ruler can balance, where gravity will pull on each side equally. All right, so I'm going to, the end, this end, middle. Let's try. I'm going to try each one. The end, that did not work. Let's do the other side. That did not work. Yes, the middle. Now, at home, you're probably thinking, yeah, Matt Andrea, that's obvious. Maybe, yes, but you have to think about why. A lot of times we know the answer to a scientific question, we just don't know how to put it in fancy scientific terms. So when you put your fingers in the middle of this straight ruler with no extra stuff on it, just a ruler, gravity is pulling on each side equally. It's pretty easy cheesy, we knew that. What about the spoon? Can I do the same way? Put it in the middle? Not so much. There's a difference, right? We've got this adorable Kool-Aid Man face right up here, and the spoon is wider. That means, whoops, there's more plastic on one end, so I have to move my fingers closer to this. So think about gravity can pull on each side equally, meaning that there's more of the handle on this side, but my Kool-Aid Man face is wide on this side. I just like Kool-Aid Man. Okay, so center of gravity. I mean, that's fun. But I'm a mad scientist, so I like to do it a little bit crazy way. All right. Balloons. Do you have balloons? Oh, no, I have balloons. Okay. They look the same. They're both blue. They both have mad science on them. They're both in red bowls. And they both have gas inside. Raise your hand if you have gas. No? Yes, you do. You have to have gas. I'll explain more in a moment. Okay. 2 balloons. But there's a little bit difference in them. Amen? So, this one just has gas. Came from my lungs. Mainly carbon dioxide gas. So, I take the balloon and, I could woohoo, play with it, bounce it around. And you know how a balloon moves through the air, right? It's fun, not super exciting, but it's pretty balanced. All right, I'm not having any problems there. I know you're impressed. Okay, this balloon, a little bit different. The difference is I have put some clay inside of this balloon before I inflated it. Okay, and what the clay does is it changes the center of gravity. Changes how gravity pulls on the balloon. We call it a bobble ball. Now, I wouldn't try to play like basketball with it, but listen. It makes a cool sound. But it also, when you toss it up, it's going to bobble around. I can do this. Okay? It wiggles a little bit. Wiggle. It might pop. Don't be scared if it does. All right? It wiggles around because of that clay is moving, and its constant motion is making gravity pull on your balloon differently than this one. Both very fun. This just adds a little bit of excitement. Now, if I had you in the laboratory with me and I wanted to toss the bobble ball to you, center of gravity, I could look right at you, right? Have the bobble ball with me and go like this, and it may not go to you. It might go over there because I can't control that. So here's my regular one. Please don't knock over the camera, okay? Here we go. Whoop. Easy cheesy. Here's my bobble one. Whoop. Well, it went towards you. But it went down there. They're in the Sarlacc pit. It's okay. If you suddenly hear a pop later, that's just science, right? That's the gas escaping the balloon in a rather fast manner. It's okay. We'll be fine. So, bobble ball is easy. You could make one. Make sure you have a grown-up's permission. You don't want to inflate your balloon too large because then your rubber that's stretched really thin, and the movement of the clay and your excitement, you're probably going to pop it easier. You know that thing. All right, so balloons, they have gas. I asked you if you have gas. You need to have gas, and I know you're probably thinking, ew, that's gross. But if you don't have gas inside of your body, it's going to be a problem. You need it to breathe, first of all. All of your cells need oxygen. Oxygen's a gas. But also, remember I mentioned our atmosphere earlier? So atmosphere is this gas all around you. It's pressing on you right now. You probably can't feel it. It's always there. Okay, so it's pushing on you with 14.7 pounds per square inch. That does not sound exciting. Okay, if you did not have gas inside of you pressing back, you would look a little odd. Okay, for example, don't worry, there's lots of balloons. Balloon. Sorry, I want to get the same color. Balloon. 2 yellows, right? They look pretty much the same. They do have some gas in. So I added some more gas. They look different, obviously. This balloon has gas pressing back, so it looks all plump and beautiful. This balloon, not enough, so it looks kind of squished, right? We have gas for many reasons, but if our bodies did not have gas and the atmosphere was pressing on us, we would kind of look like this balloon. Not yellow, just kind of squished and unusual, right? So, oh, hold on. Okay, I need this balloon. I don't want it to fly away. All right. Now, gases like to go from areas that are crowded to areas that have more space. Kind of like me, actually. I am like a gas. That's weird. If I'm in a tiny space and someone says, hey, come out here, let's play. Yeah, I want to go out there, okay? And in the world of gases, we call that areas of high pressure to low pressure. And I'm going to use air pressure to show you something pretty unusual. Okay. 2 plastic cups, mini. You stay there. Okay. Take my balloon. Now, I'm going to put it into the cup. What's in the cup? Is it empty? Does anybody know what's in the cup? Or nothing? If you think you know what's in the cup, or if you think nothing's in the cup, could you type it in chat? That would be very helpful to me. Sometimes I need, some scientific assistance. What's in the... Oh, Laura says it. Wonder if anybody else knows. If not, Laura, gold star for you. Okay. Gonna put my balloon in the cup, but that's not my question. Got the balloon, and I'm gonna answer it in 3, 2, 1. Air! It's air! I've got air in the cup and my balloon. So, check it. Oh, gas. Hello, Betty Shepard. There's a job. Whoa. My balloon is stuck in my cup. Stuck in my cup. How did I do that? I put the balloon in the cup, and then I squeezed it just a little bit, and I trapped some of that gas, some of the air in here, and then I inflated the balloon. Now, air pressure is helping the cup stay on the balloon. I'd like to show you one more thing with the balloon and the cup, but I don't know how to get the balloon out of the cup. Does anyone know how to get the balloon out of the cup? I mean, I'm pulling and it's not coming off. Out here, that air pressure is keeping it attached, keeping them attached. Oh, someone gave me an answer. Seems kind of obvious now. Haley, I hope you don't think I'm crazy, but yes, let the air out. Okay. Thank you, friends. Thank you, Betty. All right. Now I'm going to try to do it with 2 cups. Okay. So I have to be able to inflate the balloon, adding gas to it, and also trap gas in each cup, letting air pressure help me form the balloon bond. That's what we call it. All right. So air pressure inside of the cup is going to be lower than air pressure outside. And let's see. Oh, wait. Wish me luck. Yes. 2 balloon bonds. Woohoo! Yes. Okay. You may be sitting on your comfy couch thinking, well, that's easy cheesy. Is it? Maybe you should try it sometime at home. All right. So all it's holding us on is the air pressure. And just like my super smart friends have told me before, to release the pressure, I just need to allow gas to come out of the balloon, right? Thanks, gravity. Okay. We call that the balloon bond. So it's all about air pressure. I'm a big fan of air pressure. There's so many fun experiments you can do with air pressure. You should definitely try to find some books about them at the library. Just saying. Okay. Now, it's summer. I know summer's almost over, but don't worry. In the summer, I like to be outside as much as my body can handle it. Sometimes it's a little too hot. But a fun summer activity that you could do indoors or outdoors, bubbles. Okay, am I the only one that's that excited about bubbles? Bubbles! Okay, what is a bubble? Bubbles are made like from a thin film of soapy water that then you fill with gas, not gasoline. Gas, like, using your lungs and carbon dioxide. You know how bubbles work. You got your bubble solution. You can sometimes make bubble solution with your own dish soap and water. Check with your grown-ups first. But here's my question to you, as I blow a couple bubbles in a moment. Why do bubbles break so easily? Like, what's with that? Why don't they just keep going on forever? If you know, you can type it in chat. If you're not sure, it's okay. I love bubbles. But look, they're here and then they're gone. It's like blue bonnets. You have to enjoy them while they're here. I would like them to last longer. So I kind of know why they're not here very long. They're still treasured summertime activity. they're so thin. It's what we call surface tension. That little bit around the edge, even like if you have a bowl of cereal and have eaten all the cereal and you've got a little bit of milk at the bottom, even a bowl of milk the top has surface tension. Think of it like the top layer of water, like liquid. Okay, and it's really temperamental. It doesn't like to be disturbed. So in the bubble world, so many things can pop the bubble. Oil from your skin, that's not a gross thing. That happens naturally. Touching the table, dirt, wind, you name it, okay? So what I'm going to show you is a way that you can make bubbles last just a tad bit longer. And it's super fun. Okay, we're going to make lots of little bubbles. And these little bubbles are going to be attracted to each other. And when they're attracted to each other, they are less exposed to the different things that can pop disrupt their surface tension. That sounds fancy. So maybe you've done this. Maybe we're like science twins. I'm going to show you the bubble snake. Okay. This is just a little bottle, and I have a piece of fabric on the end. I cut off. I'm a grown-up. I could do it. I cut off the bottom, and I used a rubber band right there. I'm gonna dip it in this is just dish soap and water. It's not a fancy bubble solution. And get it in there a little bit. And then I'm gonna add some gas. I'm not the gas. I'm gonna use my lungs and add some gas to make some little bubbles, okay? Sometimes I get too excited about the bubble snake and I leave it in for too long. So let's see what happens. Oh, hold on. Did you see it? Oh, it broke. I have to start over. Do you like how tall I am? I'm super short scientist. Okay. So the idea of the bubble snake is you've got all the tiny bubbles, like I said, and they're attracted to each other. And so it keeps other factors from popping them as easily. Now, I don't want to take up all of our time with me on a chair, but let's see if I can get it a little bit longer. It finally broke. Ooh, look how tall I am. Hello. Okay. Super fun. Now, they're still here. See what I'm saying? Like a bubble bath in the laboratory. Woo! Not really a bubble bath. I have no rubber ducky. Check that. I do, but I can't reach him. He's way over there. Okay. So, didn't do this. It's indoors or outdoors, but I have to tell you, and if there are any grown-ups out there, I'm sure they're already saying it. Most grown-ups do prefer for bubble snakes to be outside. You can kind of see why, right? Could be a little messy. Plus, getting the fabric wet, we got gravity, pull that water down. Okay, I need to stop. I'm so sorry. I could go on and on. But look, my bubbles, they are lasting. Woo! Sorry, I'm done. Now, what fabric could you use? Someone may be asking. I just use a towel, or you could use an old sock. Not a stinky one. I wouldn't recommend that. I make sure it's washed first, okay? I'm a bubble smasher. Okay, got it. All right, we talked about our bubbles or summer activity. Now, let's talk about density. Does that sound fancy? Density. Things with a higher density, you would think go high. No, they go low. Lower density goes high. Density measures the heaviness compared to the size. Like the more stuff that's packed inside. Let's do this. I am in a laboratory. I've got some science tools. This is an Erlenmeyer flask. And I want you to observe closely with your scientist eyeballs. There looks like 2 layers. Technically, there are 3. We've got the blue layer down here, kind of a yellowy layer, and then a clear layer. Wonder what that clear layer is. Anybody know? I know what the bottom layer is. It is H2O. It is water. I made it blue with some food coloring. You're welcome. It kind of shows up better that way. So the H2O is the bottom, and that is because it has a higher density. And then this level right here is vegetable oil. And P.S., if you plan on doing some density activities in your home, your grown-ups probably going to remind you, vegetable oil, although awesome for science, can be quite messy and not so much fun to clean up. So maybe it's an outside thing. So water, vegetable oil, and gas is at the top. And everything is separated by our density. What I'm going to do is I'm going to mix it up. I'm going to add some extra carbon dioxide. What does that mean? It means I have these little tablets. Some people call them effervescent tablets. But when they go into H2O, they create gas. There's a theme, right? And when the gas, it's carbon dioxide, when the gas is created, bloop, 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 it's less dense than the oil or the water. Okay, so it's going to float up to the top, and when it floats up to the top, it's going to take some of the water with it, and it makes little bubbles. So, you can see little bubbles happening. Okay, boop, boop. See them? And it makes a cool sound that you probably can't hear because it's a little quiet. Okay. Check it out! Ooh, it's really making a lot of sound now. Okay. It's like my own lava lamp. Okay. You could get mesmerized by a lava lamp. So the gas and the water are buoyant in the oil. Like, what does buoyant mean? Think about if you are going to go on a kayak or a canoe or a pool floaty. You want them to be buoyant. You want them to be able to float on the water. Okay? All right, I'm gonna hold this back up to the camera with my T-Rex arms real quick. So you can kind of check it out. It is mesmerizing. And I know it's kind of joking, but I really could stare at it for a long time. But I'm not gonna have our last couple of minutes be me staring at this. No, I'm not. I'm just kidding. Okay, I'm gonna put this to the side. Good job, good job. Now, careful, Matt Andrea. Don't get too excited. That was a large Erlenmeyer flask. These are babies. Not babies. Baby Erlenmeyer flasks. And here's the deal. I have a liquid in the bottom. Not gonna tell you what it is. Then there's gas, of course. And then I have a solid in the balloons. And when I lift each balloon, gravity is going to pull the solid down into the baby Erlenmeyer flask, have it high-five that liquid, and then we're going to have a chemical reaction. Now, when you have a chemical reaction, there are indicators that tell you, okay? Like, hey, check it out, scientists. There's some chemicals going on. What are those things? You could have a change in color. You could create something new. You could have a change in temperature. Super exciting. You could also produce some gas. Do you know what I'm going to do? Do you know what it is? It's going to be two. Two things are going to happen. Okay, only one you will be able to observe. So here we go. Gravity's in the house. Yes, let me check. Hold on, gravity. Oh yeah, okay, we got it. So take this, pick it up. There we go. Oh, thank you so much. There we go. Now, how big are the balloons get? Depends on how much I added. And I added a lot. Okay. Oh. What's happening? That's right, chemical reaction. I have baking soda going into the vinegar in my flask, and then it's producing gas. Now, I put a lot in a couple of them, so they're heavy. Carbon dioxide is a heavy gas. But also, this is an endothermic reaction. What does that mean? It means right now on the balloons, they're cold. Endothermic is when you have a reaction and it gets cooler. Exothermic is when it gets warmer. Okay, hold on. You were my first one. I didn't put as much in you. Don't be sad. Okay, so I like to do baking soda and vinegar activities all the time. So vinegar in the bottom, which is our acid, acetic acid is its fancy name. And then baking soda was in the balloons. That is our base. And its scientific fancy name is sodium bicarbonate. So you just mix them together, and you know that you can make volcanoes and stuff, make it overflow. But how much fun is it to capture the gas inside the balloons? Okay, now, before I say goodbye, if I take the balloon and I let them go, the gas wants to escape. There's also going to be some kind of gross stuff. Now I'm coated in vinegar. All right, I want to say thank you so much to everyone for joining me in the laboratory. I hope you have had fun. I hope you are inspired to try out some science. And I hope you are also inspired to check out some sort of super cool science books so you can learn more at home. I don't know if our friends at the library have anything to say before I say goodbye.
You can say goodbye. We'll have something to follow up after.
Okay, cool. All right. Goodbye, everyone. Thank you so much. And yeah, have a great end of your summer.
Thank you so much, Matt. Is it Andrea?
Yeah, it's Andrea.
All right, Matt, Andrea, thank you so much for your performance today. We learned a lot, and it was a gas. All right, everyone. This is our last week of summer reading. So summer has really flown by. But all right, so Saturday, July 31st, it is our last day of our Tales and Tales summer reading program. It is also the last day to pick up prizes. So come by the library and pick up your prizes. We have enjoyed spending the summer with you. But don't worry, we will still be here when school starts. So come and see us. We hope you guys have a great rest of the week and come visit us at the library. Bye.